Did you know you can understand the basics of light propagation by making your own rainbow at home or in the classroom? Here is how you do it. Hello everyone, my name is Noelia Martinez. I'm a researcher at the Australian National University here at Mount Stromlo Observatory, and today we are going to learn how to make our own rainbow and the nature of the light. For this experiment, we don't need a lot of things. We need a white screen, it could just be a piece of paper. We need a mirror in whichever shape or forms you want the mirror, and we need a glass jar with some water inside. This experiment is for both junior students and senior students. I'm going to start with explaining the fundamentals of the light theory, and then later on I will go into more advanced concepts like the refraction index and the optical density of the materials for the more senior students. The first step of the experiment is to put the water inside of the jar. Then you need to be located near a window because you need sunlight directly shining on your mirror. The next step is to put the mirror inside the jar at an angle, just like that. So then you have the sunlight shining on the mirror this way and the reflection of the mirror somewhere around here. You will have to adjust the angle until you find the rainbow on your white screen. Let's try doing it ourselves now. So we'll put the jar near our window and we'll use our white screen in a shaded angle, and we'll move this until we find the rainbow on our white screen. We moved to another location and we found another rainbow over here. In this case, because we are closer to the jar, the rainbow is more clear. So now we changed the angle and then we got another rainbow, this time a bit better. So what we see here is the refraction of the sunlight through the water and off the mirror. So the sunlight is a combination of all the colors of the rainbow. So when it goes through the water and off the mirror, those colors split based on their wavelength, and then it allows us to see this rainbow. The sunlight is the combination of all the colors in the rainbow. So it's what we call white light. When the white light travels through a medium, through air in this case, it follows a path like this. However, if then the medium changes from air to water, the path is going to change and is going to bend by a certain amount. This is what we call the refraction of the light. This amount by which it's going to bend more or less depends on the wavelength of the light. And to explain what the wavelength is, we can imagine the light as a wave traveling through the medium. The wavelength is just the distance between the two peaks. Each color has a different wavelength. Some of the wavelengths are longer than others. So for instance, red will have the longest wavelength in the visible colors. And to the opposite, purple or blue, we had like the shorter wavelength. So it means the distance between the peaks will be shorter. It also means that the red color will travel faster through the medium than the purple color, because to go from A to B, the red only has to do this many turns. Into the contrary, the purple will do all these many more, so it travels slower. Because each of the colors has a different wavelength, this is what allows us to see the rainbow. When the sunlight encounters the rain droplets, the water is going to refract the sunlight light and split into all the rainbow colors. Because the shorter the wavelength, the more the color is going to bend. And that's why we always see purple at the bottom of the rainbow and red at the top of the rainbow. This is why the rainbow always appears in the same order. For the more senior students, this is what you need to know. As I said, the shorter the wavelength, the more it's going to bend. This is due to the refraction index of the medium or the material through which the light wave is going. The refraction index is a quantitative expression of the optical density of a material, which represents how well the atoms in a material are going to maintain the absorbed energy from the light wave. This refraction index depends on the wavelength, so it's going to be different depending on the wavelength of the light. This is because the closer the wavelength to the frequency at which the atoms of the material vibrate, the longer it's going to take for that wavelength to go through the material. We use the refraction index to characterize the optical density of a material. So now you are going to try the experiment again, but you are going to repeat it using oil instead of water, and you are going to discover what is going to happen to that rainbow. Thanks for joining me in doing this experiment today. I hope you enjoy it, and I hope you keep learning about optics and about light propagation through the medium. This is the very fundamentals of what we do when we observe an astronomical object using our telescopes on the ground. We use the light coming from that object, propagate it down through the atmosphere to our telescopes, and this is what we use for our scientific instruments.